Okay, today what I'd like to do is do a quick little example project. And I want you to imagine that we're writing a code for an automatic change maker. These things are really common. I can remember, though, as a young child going to Luby's cafeteria, which sadly I think just went under due to COVID. Um, and I love this little thing, this little device. It would spit out the coins in like a little like tray. Automatically would fall out of the cash register for the change that you deserved. Nowadays, though, we see these kind of applications when you do the self-checkout if you pay with cash at your grocery stores and things like that. So we're going to write a class that will help handle this. You'll need to have downloaded the change maker, the sales.txt, which has a price for the first line and a amount of money given on the next line. And feel free to add some more scenarios here and see how it works. Just make sure that they've paid more than the cost of the item. Cost on the left, pay on the right. So first we're going to create our class. And I'm just going to call it change. And some classes have a lot of work in the methods and not a lot of work in the constructor. Other classes do a lot of work in the constructor. This is going to be one where our constructor is going to have a lot of code because it's the actual constructing of the object that will be difficult. Public class change. So in order to describe change, we're going to need to know how many bills we have to give them back. Now, we could assume that they could get a $100 bill back, but to make things simple, since a $100 bill is the largest denomination, we're just going to stick with 50s, 20s, 10s, 5, 1s, quarters, dimes, nickels, and pennies. And they're all going to be integer amounts of them. So int 50s, let's make it private. Private int 50s. Private int 20s. Private int 10s. Private int 5s. Private int 1s. Private int quarters. Private int dimes. Private int nickels. And private int dimes. Pennies. So there we have it. Those are all the different values that we're going to set. Okay, now what we're going to do is we're going to work on making our constructor. Let me just move that up a little bit. So our constructor needs to be public, and it's going to take in two amounts. It's going to take in a double for the price and a double for the payment. And one of the first things that we're going to want to do is fix the fact that doubles are really not good for this problem situation. To do this problem situation, we really want to take advantage of integer division and modulo arithmetic. So we're going to convert these to integer values of cents. So instead of thinking of the $1 as being a 1, it's really going to represent 100. So what we're going to do is we're going to say int, and I'll just say P for price, is going to be price times 100, and then we're going to cast this as an int. So right now, this would have a problem. You'll see it's going to say incompatible types, possible lossy conversion from double to int. So if, let's say that we wanted to make an int x, you don't need to type this in, I just want to show you, and I had 7.3. Well, when I do that, the only thing I can store is the 7, and I would be losing the 3. So that's why it says possible lossy conversion. Java wants to warn you when, hey, you're about to lose information. So we need to tell Java, hey, it's okay. Either I just don't care about the decimals, or I know I've already taken care of it. Since our price will only have 2 decimal places. Like, for example, the first price is 123.75. Multiplying by 100 would make this 123.75. So I just need to tell Java, yes, I'm aware of it. Thank you for the warning, but I'm good. So I say this. This is called casting. I'm casting. Very important skill to have. Now, while we're on this topic, let's say I have a double x and I want to change it from an int. Notice this causes me no problems, because all x would become is 3.0. No information is lost here. I've just added a 0.0. So I don't get that error when I go what we call wider. When I go from an int to a double, it says, okay, fine. Now you have more room for information. You're just not using it. So I only get that error when I go narrower. So we'll do the same thing with payment. I can't use P again. I'll just say int pay. So I got P for price and pay for pay. So we'll say int payment times 100. And now what I'm going to get is the amount that we owe to give our change. So I'll just call that AMT for amount. We'll take the price minus the pay. So AMT is the change we need to give. We just need to give it to them optimally. Okay? So we are going to take the amount of money and we're going to tell them how many 50s do we need to put in it. So the number of 50s, now I don't say int 50s because I already declared it. These are just temporary variables to help me do my code. I've already declared 50s. Okay. Equals amount divided by how many. Remember, our amount is in cents. So I need to think, how many cents is a $50 bill? Well, there's 100 cents per dollar. So you can do that, or just say it's 5,000 cents. $50 is 5,000 cents. So that's how many 50s I need to give the person. All right, let me discuss, though, how this works. So let's say that we needed to give them $73 in change. We converted that, though, to cents. So we actually need to give them 7,300 cents. So we're going to figure out how many $50 bills by dividing this by 5,000. When we divide, 5,000 goes into 7,300 one time. And then I have to multiply 1 times 5,000 and subtract, and I'll get 2,300. This is the remainder, okay? That's how much is left over after I take out as many 50s as I can. This is the quotient, okay? So since these are integers, when we use integer division and we tell Java 7,300 divided by 5,000, we're just going to get 1. We then need to take out, we need to change amount to make amount what's left over. That's the mod operator. That's 7,300 mod 5,000. That's that. So watch as I do that next to get what's left over. I'm going to take amount, and I'm going to say amount, I want you to be amount, your current amount, mod 5,000. So this tells me how many 50s. This actually takes the 50s out. If I could fit 5 of these 50s in it, I would take out 5 of them. There is a shortcut for this. This is equivalent to saying amount mod equal. And so I'll use the shortcut. Let's find out how many 20s we need. We do 20s next by taking the amount and dividing it by 20 in cents. A $20 bill is 2,000 cents. Then we mod equal again. We need to know how many 10s. That's our amount divided by 1,000. Then our amount mod 1,000. Mod equals 1,000 takes them out. So each time I'm dividing first to figure out how many I need. Then I'm modding by that amount to take it out of the change I need to make. Next, let's find out how many 1s we need. Remember that a 1 is 100 pennies. And then I mod again. Oops, mod equals. Okay, after pennies, after 1s comes quarters. Quarters are 25 cents, so I assign it the amount divided by 25 cents. Then I mod. Now I need the number of dimes. Dimes is the amount divided by 10. Then I mod. Then nickels is the amount divided by 5. Then I mod again. And then pennies is just the amount divided by 1. So pennies is simply the amount that's left over at this point. Okay, so now, before we go any further, let's check our class to make sure that our constructor works as we expect. We're going to right-click and let's make a price. So I say let's do $15.25, and let's pay with a $20 bill. So as I see it, this should give us 4 1s and 3 quarters. If we double-click on this and inspect it, okay, that did not work. Let me figure out what's wrong. Okay, maybe you caught this earlier. This is why you should use better variable names. I subtracted the price minus the payment. I should have subtracted the payment minus the price. Please fix that on line 15. So yeah, the amount should be how much they pay. The amount of change is what they paid. Like they paid $20 minus the cost. We were getting a negative number there, but that's why we always check before we go too far. We'll try again. $15.25, and we're going to pay with a $20 bill. And let's see what happens here. It says 5 1s. Okay, that's a little surprising. Okay. One other error. Sorry. Casting actually comes before multiplication. So we were actually casting our price before we multiplied. So would you please put parentheses around this first? Yeah, we need to, I'm sorry I forgot about that. We need to, the order of operations, casting comes really early. Casting comes before multiplication and division. So I need to force it for the order of operations. Multiply by 100, then cast as an int. It was casting before it. All right, so one more time. Let's try it one more time. 15.25 and 20.00. That looks better. Okay, I'm comfortable with how this works now. Okay. The only other thing I want to do in our change class is write a toString. So remember, every object automatically has a toString, and that toString is automatically called when you print an object, but you can also explicitly call it by just saying .toString. We have to return a string, not print. So what we're going to do is we're going to make a string to return. So say string str quote quote. So we're going to start with an empty string. And what I want to do is use a series of if statements to where we only add the coin and dollar amounts if that amount's not zero. I don't want to tell someone, here's your change, 0.50, 0.10, 0.20, 0.1, 0.5, when their change is just 25 cents. So we'll say if 50s is greater than 0. So if we actually have some 50s, let's add it to the str. So I'll say str plus equals, which will add to the back, the number of 50s plus a description of it with a space after it. Okay? Now, this is a situation where you may think I will do something like else if, but else if would only happen if the previous wasn't true. Well, it's very possible that you have 50s and 20s, so I need to make a different if statement for each one of these. Then, if 20s is greater than 0, we'll add the number of 20s plus 20s. Notice that I'm putting a space before and after the word so that they don't run together. And we'll just continue with this process. And you're also noticing some encapsulation here. I could worry about formatting and all that stuff in my method that scans my data file, but I don't want to do that. I want to have all of my logic that has to do with change confined to the change objects. So now I've added more 5s. And again with 1s. If we have 1s, we'll tell them how many 1s. Then we're almost done, quarters. Oh, am I misspelling nickels? Okay. And I don't need a space on pennies because that's the last one. All right, once we're all done, remember we promised... am I misspelling nickels? Oh. Well, I don't know if I misspelled it earlier or... Y'all help me out. How do you spell nickels? Like that? R... E... Is it E-L or L-E? Okay. Okay, it's been brought to my attention that it is in fact EL. So I'm actually going to do a find and replace. Uh, so I'm going to find, I'll highlight it and say edit. It should be under edit, right? Come on. Oh, there it is. Replace. I want to replace Nichols with Nick-Els. All of them. Okay. Problem solved. But remember, spelling doesn't count in computer science. It's consistency of spelling that matters. So return str. So I promised to return the string. I built it, and now I can return it. Okay, well, all that's left is for us to write a program to scan the method. Now, we could make a totally different class just for our scanner, but instead, let's just write a scanner method here, and we'll make it static. So I'll say public static, how about run? So this is going to run our algorithm. We will need to import file and scanner from Java, so let's do that. Oh, we're missing a return statement. Void. Public static void run, because we're not returning anything. Static means it's runnable. We just click on the class and run it. So at the top of your class, please say import java.util.scanner. Import java.file. I'm sorry, not java.file, java.io.file. And we have to import this thing because we have to declare that this error could happen. File not found exception. And actually, we should add that our method could throw this exception, so we'll need to add that. Anytime you're scanning a file, you need to declare that that method can throw an exception. It's good coding habit to declare any exceptions that could be thrown. But some of them Java enforces. They don't let you be lazy. They make you. So we're going to say throws file not found exception. And that declares to our users, and it'll be in our documentation, that, hey, this could happen. All right? So first, we'll make a scanner to scan a file. There's a couple different ways we could do that. We can do it in 2 steps, or we can do it in 1. Let's look at it in 2 steps. First, we have to load a file. I'll call it file. So class name file, I'm making a file object. Variable name, also called file, but with a lowercase. New file, and the file class constructor takes the name of the file you're scanning, in quotes, with the extension. The extension is .txt for text. Next, we need a scanner to scan the file. And I'll just call it SCR for scanner. And the scanner constructor takes in what you want to scan. I want to scan the file. So we created a file object, and then we're scanning the file. If you want to do this, I'm missing the word new. They tell I'm making a new scanner. If you want to combine these 2 lines, you could just take this part here and put it inside that parentheses. But I think that's really nice and readable, that our code, when we read our code later, we can see what we're doing. We're making a file, then we're scanning that file. Some data files tell you how many lines of data there will be, and you can scan that in and scan for that amount. But this one doesn't say that, so we'll just say scr.hasNext. So we're going to enter a loop that will continue while there's more to do. Our data file just has, each line has 2 numbers, okay? So we just need to focus on how would I handle this line right here. Don't worry about how do I handle all these lines. There could be thousands of them. The while loop takes care of that. Focus just on this line. We need to scan in this number, and it's a double. Then we need to scan in that number, and it's a double. So because they're a double, I'll say double, and that's the price. SCR dot. Now we use next int, or next double usually. Because we're scanning a double, we say next double. The next number on the line, is the payment. It's also a double. So again, you have to make a variable to catch what the scanner returns to you. All right, now that we've done that, our next goal is to create a change object. So to create a change object, we need to tell Java what kind of variable this object is. It's a change. It's an instance of the change class. Now let's call it chng. New change. Now our change constructor takes a price and a payment. And now what we'll do is we'll simply print out the proper amount of change. Now I could say change.toString to call the method, but I don't actually have to because the print automatically prints it. Okay, we're now ready to try out our program. So you see the program is actually just right here. That's all the program is. All this other stuff is making the supporting class in order to do our program. If there was already a built-in change class, and you could probably find one and install it in your Java, then this is all you would have had to have done. But we're learning how to write classes that other people can use in their programs, so that's kind of part of the game. All right, notice that I now have a static method that I can run, so I just select void run, and you'll notice that it prints out, and we should double check that this makes sense. Let's see. Our first one says we need a 20, 6 ones and a quarter. Well, let's see here. We had $123.75. Add a 20, you get $143.75. Add 6 ones, you get $149.75, and add 1 quarter. So look at how it counts back our change for us. So I hope you enjoyed that as much as I did. This dividing and modding is how you should work on the time project. So hopefully this will help.